So we'll take our quick look at the calendar. Today we cover section 4.5. What happens next class on Friday? We have our quiz coming up on Friday. This is our third and final quiz. It'll work the same way as the others in that the first 25 minutes of Friday's class will be time for you guys to go over the practice quiz in the blue or something in the yellow QEF. Ask me questions, ask your neighbors questions, and then the second 25 minutes in class will be the actual quiz. Again, it's written to be 15 minutes long. Hopefully 25 minutes will be plenty of time. Note, you're going to want to bring a calculator. I will have some here to borrow. I won't let you use your cell phone as a calculator, but you can borrow mine if you need. And that's the last quiz. And I also want to say that the section that we're going to cover today, 4.5, is not on the quiz. So you've already seen all the material that's going to be on the quiz. This next section is not on the quiz. And I also want to point out this is the first time that the bottom of the calendar has been projected here on our screen. So we're getting there, right? We're past the halfway point. I guess at some point, like mid to late November is sometimes a lull for some students. We've got, we had the Monday off. We're going to have Thanksgiving coming up. And I think it's difficult for everybody to keep their motivation, to keep the momentum going because of kind of these little breaks that we have. So we're not in the home stretch, but we're at a point where I think it's a little bit dangerous for some people to kind of lose focus. So I'll just encourage people to keep on keeping on and do your homework regularly, just like you have been, even though we've got some holidays coming up and one that's just passed. Any questions on the calendar? Okay, page 195. We'll start here at the top with Caroline, the objective. Okay, so let's take a look at this following match game. So can you guys, with your neighbors real quick, decide which word goes with which thing on the right-hand side? It's possible you don't know the words, but see if you can make your best guess. Okay, the first one I see here is monomial. What does mono mean as a prefix? It means one. So which one of these has one term? B. So the monomial is B, right? Mono is one. The next one is binomial. What does bi mean as a prefix? Two. So we're looking for something with two terms, which is C. So the binomial is C. Two terms, bi. Okay. The next two examples both have the word trinomial in them. What does tri mean as a prefix? Three. So we're looking for something with three terms, but they both have three terms, which is why we need another adjective, another descriptor. So we've got this word cubic and this other word quadratic. What does cubic mean? Three, right? We know cube root. We know cube. And so the one with the cube on it is the cubic trinomial. So D is a cubic trinomial because of this x cubed, all right? So by process of elimination, I guess that means that the quadratic trinomial is A. Yeah, that's a good question. So this is a weird one. What does quad mean as a prefix? 4. Sadly, mathematicians have decided that quadratic in our case means it has an x squared term as opposed to an x to the 4th term. I think I used to know why we called it that. It has to do with area, but I don't remember. I don't remember all the details, so I'm not even going to try to make it up right now. There was some reason why mathematicians call quad something with a 2 in it instead of a 4 in it. I don't remember it offhand at the moment. But quadratic means that it has an x squared in it. Okay, so we've got these things with powers that we haven't really worked with so far. And we're gonna talk about those guys soon enough. But first, we're gonna get back to our algebra tile activity. So each of you guys has a box of algebra tiles on your table. Let's remind ourselves of what the different tiles are. So I'm gonna grab them from over here. You can use orange or yellow. I'm gonna show you yellow here. Okay, we've got the green tiles. What are they worth? Those are the ones. The small things are worth ones. Then you got the long rods. I'm going to hold up a yellow one. What are they? What are the rods? Those are X, one X. And then I'm going to hold up something that's a square with a little bit of thickness. What is that? That's X squared. We didn't play with this guy before, all right? But you have your little key down here in the lower left. X squared, X, and 1. So the first thing I need you guys to do is make 3x squared using the algebra tiles. 3x squared. Everybody have 3x squared? You need another one. 3x squared. That looks like 3x squared. 3x squared. Where is 3x squared? I don't see it here yet. Do we have it over here? This guy right here is x squared. You need 3 of those. Okay, we have it here. And we've got it over there. Okay. What about 2x plus 1? Go ahead and build 2x plus 1. Again, the key is in the lower left. 2x plus 1. 2x plus 1. 2x plus 1. I don't see it here. That is 2x squared plus 1. Where's 2x plus 1? The key is down here in the lower left. So the x's look like that. Plus 1. Good. Okay. Next thing I want you guys to do is I want you to use the algebra tiles to build this rectangle. So I want you to grab the right number of little squares and rods and little guys to build this thing. But I don't want them just anywhere. I want them actually in that configuration. So go ahead and build it. Make a rectangle. Yeah, you got to be consistent with the color. Yeah, so just stick with yellow. Okay, that's looking good. Good, good. All right, almost there back here. Okay. Next thing I want you guys to do is here in part C. It says give a quadratic trinomial. We just saw what that was, but you don't even need to worry about that at the moment. That represents the area of the algebra tiles circled in red. You're going to have to look at my board up here on the right in the above picture. So this thing over here on the right, I want you to tell me what the area of that whole accumulation is. Or I guess just what does that collection represent? So first, what are these big squares worth? That's x squared. So how many x squared do you have? 2x squared plus, and then you keep reading and you keep writing. So just write down what that collection is. 2x squared plus. Okay, that's good there. Okay, so what do we end up with here? 2x squared plus 7x plus 6. Yes, that's what that represents. Okay, and then just a reminder again of our little key. We talked about it. It's here in purple in my diagram, but notice that that there are some dimensions here along the sides. So for your little green cube, we're saying that this side is 1 and this side is 1. And so what's the area of the front face? 1 times 1 is just 1. That right there is the same 1, but here we're just going to call that x. And so what's the area of that rectangle? Is 1x, or just x. And then this guy right here is x, and this guy here is x. So what's the area of that rectangle? It's a square. It's x squared, right? X times x. Okay. So what I want you guys to do is find the length and width of the rectangle that you made. It's still sitting there in front of you. It's the one circled in blue on my board. So write down the length and write down the width of the rectangle that you made. So it's this rectangle here. How long is it going this way, and how wide is it that way? Poor Henry can't see the rectangle we're doing here. So we're looking for the length and the width, that guy. Okay, so let's see if we can come to some agreement here. Let's take a look at this distance here to here. How much is that? That's 2x, right? 2x there. And then I'm going to look at this distance here to here. How much is that? That's 3 single ones, right, going that direction. So that right there is 3. So then how long is the whole top? 2x plus 3, yes? That's the whole top going across. And then let's go down the side from here to here. How long is that? That's just a single x. And then we'll do green for here. How long is that? That's 2. So then how long is the whole side? X plus 2, right? So 2x plus 3 is the length, and x plus 2 is the width. I'll put it down here. The length is 2x plus 3, and the width is x plus 2. Yes? Okay, when we're ready, we'll go to the next page. And now our conclusions. So the first question, how can we use the length and width to get the area of the rectangle that we made? Yeah, if I just asked you for the area of the entire big rectangle here, you guys know the area of any rectangle is length times width, right? And so the area of this rectangle is just 2x plus 3 times x plus 2, right? Okay, so multiply them is what we have to do. And then part 2, how does the area of the big rectangle that you guys still have on your tables compare to the area of the collection of algebra tiles circled in red? Again, you might want to look up here. So that's this one in the top right. So compare the collection of tiles that you have on your table to this collection over here in red. It's the same. We had 2x squareds. They're just moved around, right? Like those 2x squareds are here in the top left. There are 7 of these x tiles here. 1, 2, 3, 4, 5, 6, 7. They're there. They're just moved around a little bit. And then finally, how many of the single guys are there? 6 of them. And are there 6 of them in there? Yes. So they've just been shuffled. So how does the area of the rectangle on your table compare to the area of the collection? They're exactly the same. So we're going to summarize this with an equation that looks like a product of binomials equals a quadratic trinomial. Now that's new vocabulary, so don't stress about the vocabulary at this moment, but let's just write the equation. We said to find the area of the rectangle on the table, we're going to multiply length and the width. What was the length of the rectangle? It was 2x plus 3. And what was the width of your rectangle? X plus 2. And if I want to find the area of your rectangle, what am I doing? Yeah, I'm multiplying them But I can't write it like this because here it looks like I'm only multiplying the 3 and the x. So separate parentheses, you don't need the dot in the middle. But that right there is a length times a width. That's the area of the rectangle on your table. But then separately, you guys wrote down the area of the collection of tiles pictured in top right. What was the area when we just gathered all those tiles together? It was 2x squared plus 7x plus 6, right? And we have to believe that these things are equal because it was just the same collection of tiles shuffled around, just regrouped. Okay, and do we buy the vocabulary? A product of binomials? Do you see a binomial in each set of parentheses? Binomial again means two terms. A product, we're multiplying them, is equal to a quadratic trinomial. Trinomial means three terms. We see it. Quadratic, unfortunately, means squared. And that's what we have. Okay. So number 3. How do we get from the product of binomials, that's this purple thing, to the quadratic trinomial, the red thing, directly without pictures or algebra blocks? So we've got this fact, this thing we believe to be true. I want to show you a way to get there without referencing these algebra tiles. Okay, so here we go. 2x plus 3 times x plus 2. All right, I'm going to show you something that Sandy uses, and it's called lobster claw. And so here's the idea. We're going to take this 2x right here, and we're going to distribute it to the x and to the 2. And so I'm just going to start writing now. Equals. So when I multiply the 2x times the x, what do I get? 2x times x is right here, and that is 2x squared, right? It's multiplying the 2x times the x. Next thing, what am I going to multiply? 2x times 2. Let's put that next. 2x times 2. What is 2x times 2? That's 4x. Just shuffle the 2's around so they're next to each other. And is it a positive 4x or a negative 4x? It's positive, right? Because you're multiplying two positive things together. Okay, and so I'm done with this 2x in the front. It has distributed through everything in the back, but I also need to distribute this 3. The 3 needs to hit the x, and the 3 needs to hit the 2. So we're going to multiply the 3 by the x and put that here, and then we're going to multiply the 3 by the 2 and put that there. Okay, silly question. What is 3 times x? 3x. And it's positive because everything was positive. And 3 times 2? 6. So we get this. So this is just a double distributive law. Everything in the first set of parentheses needs to multiply by everything in the second set of parentheses. Do we see the lobster claw here? Yeah. Yes? Some of you guys maybe have memorized this with an acronym. This FOIL. Raise your hand if you FOIL. If you liked FOIL, continue to FOIL. But if you don't understand FOIL, do this lobster claw. Okay, so that's it. And then just one last thing to clean this up. 2x squared plus 4x plus 3x, they're like terms, so we can mush them together. We have 7x there, plus 6. Which is exactly what we got up above, right? So this is how we can get to the answer. If we have to multiply two binomials, you don't need to think about algebra tiles. You can just do this process. Okay, let's see. Number 4, doing the lobster claw gave us 4 terms before we combined to get the 7x. It was really a 4x and a 3x. I want to show you that they appear in the rectangle that you guys built. So let's see if we can find them. Can you guys find the 2x squared? Maybe just pull them off the rectangle just a little bit. Not too far away. I still want it to look like a rectangle, but everybody see the 2x squared? And then what about this 4x? Can you pull them off just a little bit? Right? The 4x's are there in the lower left of your rectangle. Yeah. And then the 3x, where are they? They're in the upper right of the rectangle. And then the 6 is the lower right. Right? And so you can see there's kind of these 4 different pieces, and they come very naturally by multiplying, one thing by another. And there's a real good reason for that. When I first saw this idea about multiplying binomials, I just memorized it, but I didn't understand the physical nature of this thing. But for example, if I look at this guy as being a separate rectangle, just a smaller rectangle inside the big one, what's the length of this rectangle? X. What's the width? 2x. How do I find the area of that rectangle? Multiply. 2x times x is 2x squared, right? And then let's look at this next piece over here. That rectangle. What's the length? X. The width? 3. Multiply to get the area. 3x. And then down here, what's the length? 2. Width? 2x. Multiply them. 4x. And then finally this guy over here. Length is 2. Width is 3. Whole thing is 6. So those 4 terms appear very naturally. There's something that they represent. They each represent a smaller rectangle inside of the big rectangle. All right, let's see. So how to multiply this product using a rectangle diagram. Essentially, it's what we just did. I'm going to draw a rectangle, and it's not going to be to scale. But this is my very rough representation of the big rectangle that's on your table. And regardless of how long or how wide the rectangle actually is, I just always draw like a square with 4 squares in the middle. And now we're going to fill in some of these pieces. At the top, it was a 2x plus 3 or 4? 3, right? That was 2x. That was 3. And on the side, x and 2. So I encourage you guys to make this diagram in this space here on number 5. That's an important one. And I've got 4 spaces to fill in this diagram, and every one of them we're just going to be multiplying to get areas. So if we do 2x times x, what do we get? 2x squared. And then I'm going to do this 3 times this x. It's 3x. And then we're going to come down here, and that 2x and that 2. What do we get when we multiply them? 2 times 2x is 4x. And tell me I have one more color. This 2 times this 3 is the 6. So do we see how to make this diagram? Like if I gave you the things on the top and the things on the side, could you fill in the 4 boxes inside? Just a matter of finding the right length and multiplying it by the right width. Okay. And then the last thing here, number 6, the lobster claw idea and the rectangle diagram can be generalized to other products. So for example, the one that we just did, well, I'll just make up one here. If I had something like x plus 5 times 3x squared plus 2x plus 4. What's in the first parentheses? What's that called? That's a binomial. In the second parentheses? It's a quadratic because of the squared. Trinomial because there's 3 terms. So I said you can continue to do FOIL if you've had success with FOIL in the past. The real downside to FOIL, and the reason I never teach FOIL, is that it doesn't work in any case other than what we just had up above, binomial times binomial. It's completely useless for anything else. It only works for binomial times binomial. So FOIL doesn't help me at all multiplying these two things together. But the basic idea of the lobster claw still applies. Everything in the one parentheses times everything in the other. So we're not going to do it out, but we can draw in the lobster claw. This x is going to multiply by the 3x squared, and it's going to multiply by the 2x, and it's going to multiply by the 4. And what happens next? 5 comes in and hits everybody. So like a double lobster claw thing. So FOIL might be memorable, but it is very restricted in terms of its use. So I'd encourage you to learn something additional to FOIL, even if you like FOIL. Okay, and then one last note here. It says at times, like on homework or quizzes or exams, you'll be asked to find a product using a rectangle diagram. So you got to make sure you know how to use this method. That's what we did here in number 5. Okay. All right, so you'll see some of that in the homework. And why don't you go ahead and see how far you can get on the classwork. Raise the flag if I can help.